Solar cells, also known as photovoltaic cells, are a type of electronic device that can convert sunlight into electricity. They are a crucial component in the growing field of renewable energy, as they allow us to harness the power of the sun and generate electricity without producing greenhouse gas emissions or relying on fossil fuels. Solar cells have become increasingly important as the world looks for ways to reduce its carbon footprint and transition to a more sustainable energy system. The basic principle behind solar cells is the photovoltaic effect. This effect occurs when photons from the sun's rays strike the surface of a solar cell and knock electrons free from their atoms, creating a flow of electric current. In order to make this process more efficient, solar cells are made from materials that have specific electronic properties, such as silicon or other semiconductors. These materials can be treated in various ways to create a thin layer of positively charged material on one side and a thin layer of negatively charged material on the other side, creating an electric field that helps to guide the flow of electrons. Solar cells can be found in a variety of applications, from small devices such as calculators and watches, to large-scale power plants that can provide electricity for entire communities. They are particularly useful in remote areas where traditional power sources are not readily available, as they can be installed to provide a reliable source of electricity without the need for expensive transmission lines. As the technology behind solar cells continues to evolve, they are becoming more efficient and cost-effective. This has led to a rapid expansion in the use of solar energy around the world, with countries such as China, the United States, and Germany leading the way in terms of installed capacity. Despite this progress, however, there are still challenges to be overcome, such as the need to store solar energy for use when the sun is not shining. Nonetheless, solar cells remain a promising and exciting area of research, and they are likely to play an increasingly important role in our energy system in the years to come. Solar cells are manufactured using a variety of materials and manufacturing processes, with the most common materials being silicon and other semiconductors. The manufacturing process typically involves several steps, including wafering, doping, texturizing, metallization, and encapsulation. Wafering is the process of cutting thin, flat discs, or wafers, from a larger piece of silicon or other semiconductor material. Doping involves introducing impurities, such as boron or phosphorus, into the silicon to create a p-type or n-type semiconductor. Texturizing is the process of etching the surface of the wafer to create a rough surface that can better capture sunlight. Metallization involves depositing a thin layer of metal, usually silver or aluminium, onto the surface of the cell to collect and conduct the electrons. Finally, encapsulation involves sealing the cell within a protective layer of glass or plastic to protect it from the elements. Other materials used in solar cell manufacturing include cadmium telluride, copper indium gallium selenide, and perovskites. These materials are typically used in thin-film solar cells, which are lighter, more flexible, and less expensive to manufacture than traditional silicon-based cells. In recent years, there has been a growing interest in using organic materials, such as polymers and carbon-based molecules, to create solar cells. These materials have the potential to be even more lightweight, flexible, and low-cost than existing technologies, although they are still in the early stages of development. Overall, the choice of materials and manufacturing process used in solar cell production will depend on a variety of factors, including cost, efficiency, durability, and environmental impact. As the technology continues to evolve and improve, we are likely to see a wider range of materials and manufacturing processes being used to create more efficient and affordable solar cells. The VI characteristics, or current voltage characteristics, of a solar cell describe the relationship between the current flowing through the cell and the voltage across it. The characteristics of a solar cell are an important factor in determining its performance and efficiency. Under illumination, the current voltage relationship of a solar cell can be described by a curve that begins at the origin, 0 voltage, 0 current, and rises steeply, reaching a peak at the maximum power point, MPP, which corresponds to the voltage at which the cell produces the most power. Beyond the MPP, the curve begins to level off and eventually reaches a plateau known as the short-circuit current, ISC, where the voltage is 0 and the current is at its maximum. On the other hand, when the solar cell is not illuminated, the VI characteristics follow a different curve known as the dark current voltage curve. This curve describes the current voltage relationship of the solar cell in the absence of illumination, and it is used to determine the leakage current and other parameters that affect the performance of the solar cell. The VI characteristics of a solar cell are influenced by a variety of factors, including the materials used in the cell's design, and the operating conditions. For example, the efficiency of a solar cell can be improved by increasing the voltage at the MPP or reducing the resistance of the cell. Additionally, the VI characteristics of a solar cell can be affected by external factors such as temperature and shading. Overall, the VI characteristics of a solar cell provide important information about its performance and efficiency, and they are a key factor to consider when designing and optimizing solar cell systems. By understanding the characteristics of solar cells, researchers and engineers can work to improve their performance and efficiency, making solar energy a more viable and cost-effective source of electricity. Solar cells offer a number of advantages as a source of renewable energy, but there are also some disadvantages to consider. Here are some of the key advantages and disadvantages of solar cells. Advantages: renewable energy. Solar cells harness the power of the sun, which is a renewable and virtually inexhaustible source of energy. No greenhouse gas emissions. Unlike fossil fuels, solar cells do not emit greenhouse gases or other pollutants that contribute to climate change. Low operating costs. Once installed, solar cells have very low operating costs, as they require no fuel or other consumables to produce electricity. Long lifespan. Solar cells have a long lifespan and require very little maintenance, making them a reliable source of electricity over the long term. Versatility. Solar cells can be installed on a wide range of surfaces, from rooftops to large-scale solar farms, making them a versatile option for generating electricity. Disadvantages. High upfront costs. The initial cost of installing solar cells can be high, which can be a barrier to adoption for some homeowners and businesses. Intermittent power source. Solar cells only produce electricity during daylight hours and are dependent on weather conditions, which can limit their reliability as a primary source of electricity. Land use. Large-scale solar farms require a significant amount of land, which can have an impact on natural habitats and ecosystems. Energy storage. Solar cells produce electricity when the sun is shining, but energy storage is required to provide electricity during periods of low sunlight or at night. Energy storage systems can be expensive and add to the overall cost of a solar cell system. Efficiency limitations. Solar cells have limitations in terms of efficiency, and they are not yet able to capture all of the energy from the sun's rays. This means that a significant amount of sunlight is lost as heat, which reduces the overall efficiency of the solar cell system. Overall, the advantages and disadvantages of solar cells must be carefully considered when evaluating their potential as a source of renewable energy. While solar cells offer many benefits, there are also challenges that must be addressed in order to make them a viable and cost-effective option for generating electricity. Solar cells have a wide range of applications and uses, ranging from small-scale portable devices to large-scale power plants. Here are some of the most common applications of solar cells. Residential and commercial electricity generation. Solar cells can be used to generate electricity for homes, businesses, and other buildings. Rooftop solar panels are a popular choice for residential and commercial installations, while large-scale solar farms can provide electricity to the grid. Off-grid power. Solar cells are often used in remote locations where access to electricity is limited or non-existent. Portable solar panels and battery systems can provide power for camping, outdoor events, and emergency situations. Transportation. Solar cells can be used to power a variety of transportation systems, including electric cars, buses, and trains. Solar-powered boats and airplanes have also been developed. Consumer electronics. Solar cells are used in a wide range of consumer electronics, including calculators, watches, and phone chargers. Portable solar panels and battery systems are also popular for charging devices while on the go. Space applications. Solar cells are used to power satellites and other spacecraft, where they must be highly efficient and reliable in extreme environments. Agriculture. Solar cells are used in agriculture for a variety of applications, including powering irrigation systems, water pumps, and livestock feeders. Environmental monitoring. Solar cells are used to power a variety of environmental monitoring systems, including weather stations and air quality sensors. Overall, solar cells have a wide range of applications and uses, and their versatility and reliability make them an important source of renewable energy in many different industries and settings. As technology continues to improve and costs continue to come down, the use of solar cells is expected to continue to grow in the coming years.